In this video, I'm going to show you how to solve the ALEKS problem called using the ideal equation of state. The ideal equation of state is just a fancy way of saying the ideal gas law, PV equals nRT. In this problem, we are going to be given 3 variables and asked to solve for the 4th, keeping in mind that R is a constant, so they're probably not going to give us that variable. They just expect us to know that. So we're going to go through this problem and just identify the 3 variables that are given to us. First, we have the temperature. The reaction is taking place at 27.0 degrees Celsius. Remember, in the ideal gas law, the temperature needs to be expressed in units of Kelvin. So we can just go ahead and do that conversion right there. 27 degrees Celsius plus 273.15. That's going to give us the temperature in Kelvin. 273 plus 27 is 300.15 Kelvin. It also tells us that we have 788 millimoles of boron trifluoride gas. 788 millimoles. That's a unit that you might not be familiar with, a millimole. This is just putting the metric prefix milli in front of the mole unit, which is totally valid, and it's actually relatively common. So we can convert this into moles the same way we would do any sort of milli conversion. Divide by 1,000. 788 millimoles is 0.788 moles. And let's just kind of make a note over on the side. 1,000 millimoles is 1 mole. It's asking us to calculate the volume, so that's the variable that we're being asked to solve for, and we can assume that the pressure is exactly 1 atmosphere. So that one is one that we don't have to do any unit conversion on. Let's go ahead and plug all of this stuff into PV equals nRT. I'm actually just going to start right off the bat by rearranging this equation to isolate the volume variable, since that's the variable that I'm solving for. So to do this, I'm just dividing both sides by P and rewriting the equation down here. The value of N is 0.788 moles. R, the ideal gas constant, is 0.08206 or 0.0821, depending on how many sig figs you like to use. The units are liters times atmospheres over moles times Kelvin, and the temperature in Kelvin is 300.15. And we're going to divide all of this by the pressure in 1 atmosphere. And you can just double check to make sure that your units are canceling out correctly. This is just a way of making sure that you've got this problem set up correct. When we plug all of this into our calculator, we get an answer to, ALEKS wants 3 significant figures, 19.4 in units of liters.